Okay, we're in section 124. As always, there'll be contents, examples, and exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra dating back to 1904. The actual PDF, by the way, is being made available to the participants in the Prison Mathematics Project. I realize other people may be watching these videos, and if you're a teacher or a student and you're interested in getting a copy of this document, it's not published yet, but I will publish it. And if you're interested, what you do is just email me, let me know you're interested, and then I'll update you about when it becomes available and how to get a copy of it. All right, so this section over here is, location of roots. And for the most part, I'm trying to locate roots on integer intervals because it's easier for me to do that. So my claim over here, if I'm doing integer intervals, what I really want to get is sort of like, looking at the problem, having some sense about what it looks like. And let me write this down for you, what I mean by that. And certainly, this is f of x equals x cubed minus x squared minus 6x minus 7. I just noticed something. This guy Deming, he said something, if you can't describe what you're doing as a process, you don't know what you're doing. Deming, at the end of World War II, he's American. He was told to go to Japan and improve their manufacturing capabilities because they were just devastated after the war. And the Japanese, prior to World War II, were not known for high-quality manufacturing, right? So Deming went there, and what he taught the Japanese manufacturing people was quality control. And by that, what he did, he looked at everything as a process to be analyzed, and the Japanese really did take advantage of his idea of quality control. It's statistical analysis, and they listened to him, and they really listened to him because the Japanese nowadays, right, you may not realize this, they came into the automotive market, I'm going to say, probably the big time during the 1970s. And what they started to do was make cars a lot better than the Americans were making cars. Number one reason, they really paid attention to Deming in quality control, whereas the Americans did not pay attention to Deming. All right, they were making cars that were falling apart in the 70s. All right, but the Japanese really got this down in the 80s and 90s. They really made some really substantially great products, not just cars, by the way, also electronics and things like that. Certainly, this has moved. Other great companies in quality control, I'd say Apple Computer certainly pays a lot of attention to quality control as well as there. Anyway, let's get back to the real story. The real story is me analyzing this, all right? So I do know what cubics look like, by the way, and I'm going to say, generally speaking, something like this over here, all right? Something like this over here. So I know the shape of this curve looks something like that over there. I'm not saying exactly like that, but something like this over here. So I'm looking for upper and lower bounds and roots. And, the cardinal rules of sign's not a bad idea, and I'll put that down for you. So what do I see? Positive, positive, negative, negative. So what do I know? I know there's one sign change. All right, so remember. So there's one sign change, so S equals 1. So what does P have to be? P has to be 1. So I know there's one positive root. I know that. I know there's one positive root. That's really important, by the way. So if I know there's one positive root, I want to get a bound for it. All right, so I'm not going to do what I did in the last chapter. I'm just going to look around. I know there's a positive root, so I'm going to look at it, and I want to look at a number. And I'm going to start looking at integers, all right? I want to point out what I mean by that. I'm going to look at, integers, and I'm going to start just in a positive direction. So I know if I plugged in f of 0, and let me remind you, this is f of x, it would definitely be a negative number. And if I tried f of 1, let me go back up here. Really easy to do, by the way. You would get 1 minus 1 minus 6 minus 7. Definitely a negative number. If you try f of 2, a little more challenging for me. I'll write this down for you. You can get 8 minus 4 minus 12. Oh, you know what? That's a plus sign. Sorry about that. Minus 12 minus 7. Let's see if I did that right. Yeah, definitely negative number. So it's negative. So, I'm saying, so I got negative, negative, negative. I got to keep going. Let's go to 3. Once it punctures it, though, I want to point out, once it punctures through, I know this isn't going to sail off forever. So I'm going to try f of 3 now. And what do you get over there? 27 plus 9 minus 18 minus 7. 27 plus 9 is 36. Minus 20, definitely positive. So what do I now know? F of 3 is positive. So what do I got? At 2 and 3, 2 is going to be negative, 3 is going to be positive. It punctures it. So I know there's a root between 2 and 3. That's really important for me. So I'm seeing a root between 2 and 3. Now what I need to do is I need to do the negative roots. I don't know if it has any, but I need to look at it. So let's take a look at it. So we're going to rotate it. And, you know, I'm just going to rotate it once, by the way. And let me put this over here for you. And, well, notice I just rotate it once. That's all we need to do. So let's put this down, f of minus x. I know when we did that chapter, I rotated it twice about the x and y axis, but I'm just looking for roots. Let's take a look at that. What do you get? You get minus x cubed, right, plus x squared, plus 6x, minus 7. Let's make sure I did that right. Yeah, I did okay. Minus, plus, plus, minus. How many sign changes do we get? We got 2. So s equals 2. Right? So what do you got? S minus p has to be a non-negative even number. So what could p be? P could be 0 or p could be 0. Up 2. I don't know. We got to check it. All right? So what I need to do is we're going to look below the 0 now. And I'm either going to get, you know, something, I'm going to look for them, but I think we did f as, let me write this down for you. I forgot what f of x is. And again, I'm going to get 0 or 2. Let's take a look. It's x cubed plus x squared. Again, I'm just looking at integers. Minus 6x minus 7. Well, I did f of 0. Let's do f of minus 1. What do you get there? Minus 1 plus 6 minus 7. That gives me a negative number, right? So I know it's negative, negative. No signs change yet. Let's do f of minus 2, though. What are you going to get? Minus 8 plus 4 plus 12 minus 7. What do you get there? Minus 8 plus 4 is minus 4, and then 8. Oh, look, positive. All right, let's keep going. I got a sign change there. We'll discuss that later. Minus 3. Let's see what happens over there. What are you going to get? Well, you get what? Minus 27 plus 9 plus 18 minus 7. Well, let's take a look at that. What do you get? You get, that's negative. So I got something interesting happening here. I'll point out what I got. We got a sign change between these two. I'll put that down for you. So between minus 2 and minus 3, what happens? At minus 2, it's up here. You get the idea? Let's do the minus 1 too. I'm sorry about that. At minus 1, it's below. At minus 2, it's above. At minus 3, it's below. Oh, I got crossings. So now I know. What do I know? I'll put the picture down for you. Between 2 and 3, it's puncturing it. 0, I know it's negative. Between minus 1 and minus 2, right, I know this. This is minus 1, minus 2. You know what? I get a better picture. Let me erase this. This is not a good picture. Let me put this down for you. 1, 2, 3. 1, 2, 3. And I know I got there's definitely a negative I'm not saying what the number is. It's actually minus 7. I don't need to do that. Between 2 and 3, I got a puncturing. I know this. Something like this. We've already shown that. Let's see, between minus 1 and minus 2, we got a puncturing. Now let me discuss what's going to, from the 0 to minus 1 is definitely negative. So I got this part over here. Again, I'm not saying it's a perfect picture. Then it goes positive. And then between minus 2 and minus 3, over here, it goes negative again. All right, so I got this over here. Now, by the way, I know the roots are between, let's make sure, between 2 and 3. Let me point out what this is over here. I know there's a root between minus 3 and minus 2. That's over there. I know the root between minus 2 and minus 1. All right, I know this, right, just by simple sign analysis. So let's look at the better picture, if they have it. Yeah, they got it. I'm seeing that over here. I'm seeing this one over here. And that's all we're doing, right? Some simple, bounding where the roots would be, and hopefully they're not too bad to do. There's going to be some exercises to get through. Cubics are really easy to analyze. I'll point out what I mean by that. This thing's going to sort of look like this over here. All right. Now, when I do that, I'm not saying exactly what it looks like, but sort of like this S-shaped curve over here. Now, I know it opens up like that, functional. You do some rotations, things like that. Look for bounds. We do that. And certainly we give you pictures. And the reason we give you pictures, we want you to look at the pictures. And all we're doing is we're bounding the roots through integers. That's all we're doing. So we're going to say between minus 4 and minus 3, between minus 2 and minus 1, and between 1 and 2. Likewise over here, cubic. What I mean by that, this is a cubic. I know its general shape. Its general shape is going to look sort of like this over here. Let me get my pen out. Like this over here, sort of. I know it has a general shape like that. And again, we go through this bounding. And sometimes it takes a lot of time to get the bounds of it, but I do it for you. I want to point out we found one of the roots was between 5 and 6. We found another root between 1 and 2, another between minus 1 and 0. All right? Fourth degree polynomial is more difficult. I'll tell you why. General shape of it, it could look sort of like this over here. Could look more flat like this over here. But anyway, don't worry about that so much. I know it has a general shape like that, but my understanding is getting bounds on the roots and finding what integers is between. And again, a lot of it's just sandwiching things, all right? And again, you discard rule of sign. They give you a picture. I'll point out what I mean by that. I'm seeing roots here, all right, like a root between minus 2 and minus 1, another root between minus 2 and minus 3, a root between minus 1 and 0, and a root between 1 and 2. We're just bounding it integer-wise. It's so much easier just to deal with integers and nothing beyond that. All right? Each of these problems, I do that. Every single problem. All right? And again, it can be tough. I use the card rule of signs. Sometimes I solve inequalities. It gets a little involved. The more work you put in, the more time and effort you put in, the more you get out of this over here. All right? So again, a lot of work is down there. Yeah, I spent a lot of time doing these problems. Eventually get to Sage. What's Sage? Computer algebra system. It's open source. Go to this website. Either download it or interact with web-based application. And you can see me playing around with Sage as far as evaluating functions, maybe finding roots, things like that. It's not bad. What's the intention over here? Not for you to use Sage, but for you to get busy with Wells's work. My email address, again, is ban, that's B as in boy, the @ symbol, nnon.us. Why do we give you the email address? So you can reach out to us if you have troubles. All right, like if you're doing problem number 7 and you think I made a mistake, reach out to me. Say, you made a mistake, here's the mistake, and let me know where you found that mistake. And I'll be more than happy to give you credit and correct the notes. Other people will also be thankful for you doing that. I'll tell you why. The better these notes become, and the more useful they become to other people, all right? Not just now, but in the future. Thank you so much for listening.